All right, thank you, Ken. So I'm going to try to get you all oriented to what the system is, how it works, show you some examples, some demos, just so you have a sense of what it is and what it isn't. And if you're interested, I'll be available afterwards. You can always follow up with me and get more info. So TELLab. TELLab's a free online platform for learning by creating psychology experiments. And this is experiential learning. And most of the students start by participating in experiments. So we've got experiments that you can participate in. And then you can download your own data right after participating in the experiment. And that's really useful because students have the experience. They just looked at the stimuli, they just pressed the button, and now they see an Excel file with the data that they generated. So it's really hands-on. It gets you right into the sense of where did these data come from, how were they generated, and then we build up from there. So the sort of feature of the website is a GUI editor for online data collection. So students can build experiments without any programming experience. They can, one important feature is they can copy and modify existing experiments. So if they take a Stroop test or a flanker experiment or a multiple object tracking experiment, they can copy that whole experiment right into the editor. And then they can modify it. They can change the parameters. They could change the timing. They could swap in different stimuli if they want. So it gives them a really easy, accessible way to start fiddling with an experiment, to start making small changes and thinking about how all the choices that go into an experiment might matter, might impact how participants behave. It also lets them build new experiments from scratch. So you can sort of choose your own adventure, build new experiments. And then really importantly, lets them collect data online. So they can post a link, they can share it on Facebook, they can send it over email, they can put it on Slack for the rest of their class. So you can collect data from their friends, from their classmates, from whoever. So this is really, in a nutshell, that's what TELLab 1.0 is. So the system was sort of envisioned by Ken and built by Na Li about 6 years ago. I've been using it for the last 5 years in my classes at Princeton, teaching research methods, intro to psych, cognitive psych, and a number of other classes. And it's been great for the students. They've really gotten their hands-on learning experiences. So I'd like you all to create an account right now. And you can go to this URL, lab.tellab.org or just tellab.org. It's free. I'm not going to send you any spam, and it takes about a minute. And once you've created an account, then you'll be able to participate in demos, and you'll generate data that
Uh-oh, the site went down. Uh-oh.
Justin, we can't hear you.
I think because everybody's signing in, is that the problem?
The site.
This is a Zoom thing, so.
Yeah, Zoom's independent of that, so it shouldn't matter.
Yeah.
That's right.
Well, maybe while we're
Should I call him?
You could call him, or we could, for those
people can sign in right now. Okay.
For those
that might mean you got
go
dumped.
ahead and create your account.
Are people creating their account?
And he's back.
Is he back, Justin?
Yeah, I'm trying to.
Yeah, my internet went out. Sorry, it's spotty.
You disappeared, Justin.
I'm back.
But it was perfect timing because it gave folks some time to make accounts.
Okay, hopefully a good number of you have accounts now, and I'll continue.
Anybody have an account? People have accounts?
Yep, we got our account here.
Great.
Yes.
Great.
Feel free to say in the chat if you need another 30 seconds.
Go to the chat. Let's look at the chat here. I should be looking at if there's any complaints here. Okay. Speak up.
All right, I'm gonna continue. So why use TELLab? Why should you try out TELLab? The first reason is the best way to learn is by doing. I feel like research methods classes and labs in general, just telling students about experiments, about how they're designed, is really hard to learn. It's like telling somebody how to cook or ride a bike. You've got to do it to really understand it. So there's some nice features of TELLab. It's all online. and there's no coding required. So it gets students quick access to designing experiments and collecting data. And the basic functionality is the ability to display stimuli and collect response time and accuracy data. So you can do a lot with that. I'll show you some examples, but then there's also some more sophisticated functionality on the site as well. And I'll refer to these as experiment design templates. They basically let you quickly build any number of different types of experimental trials. And some of them will let you build an entire experiment just by entering stimuli. So we've got a few use cases for that I'll walk through a couple of them. And some examples of the design templates. We've got a way to quickly make change detection trials, multiple object tracking trials, visual search. We've got card sorting for doing rankings, short-term memory experiments. We've got a wizard that'll build an implicit association test and several others as well. So before I sing the praises of TELLab, which I think there are many, I want to put some caveats out there that this system, it was built by Na Li, a brilliant programmer. She left after building this for industry. She's at Google now. And so the site right now is 1.0. It doesn't work for everything. It's not great for making surveys. If you want to do survey research, it's not the VSS crowd, but if you're sharing this with colleagues, tell them to use Google Forms or Qualtrics. And not all designs. So there's some elaborate designs. If you need to have 500 different stimulus screens, TELLab's not great for that. But it does do a lot of things really well. I'll get into that. So the site is as is. There's minimal tech support for version 1.0. So you can go ahead and try it out, see what works for you. I think you'll appreciate it. And version 2.0 is under development. Jeff Mulligan's currently building 2.0. It's going to have more features. It's going to have more support. And he's going to tell us about what he's currently building right now. Well, at the end of this presentation, after I talk and after Jeremy Wilmer shows us some examples of data analysis. All right, so to participate in experiments, you can navigate to lab.tellab.org, probably already there since you just created an account. And I want you to click on this link, experiments. And then when you get to the experiments, click on multiple object tracking. And now once you're on the multiple object tracking page, you're going to see a bunch of these blue rectangles, but just go ahead and search in your browser for VSS. And if you're on a Mac, that's Command F. That'll let you search for VSS, and you'll find a demo. So VSS 2020 MOT demo. And then when you hover over that icon, there's going to be two icons that appear. And the left one, the chain link right there, you can click on that to participate. And that's going to launch you right into an MOT experiment with just 3 trials, but I'd like you to go ahead and do it. And I'm going to pause for 30 seconds because they're quick trials. So go ahead and participate.
So I'm pressing a key and it's not beginning.
Try clicking on the box where it should begin. Sometimes if you're outside of that window, it won't work.
Yeah, you got to keep your cursor inside the window.
Uh,
Anybody getting multiple objects?
Yep.
where am I supposed to click? I clicked in the box.
Yeah.
Nothing.
You see the stimulus frame?
No, I see a thing that begins, could you, welcome to the VSS 2020 TELLab.
Yep, and then click any button to begin. Any key on your keyboard.
Sorry, Angela, I just muted you so that we didn't get the feedback. But hopefully
I'm going to continue, and Angela, we'll come back to you, and we'll be able to help if it's still not working later on. But Hopefully a good number of you just participated in 3 MOT trials. So once you're all done, you'll see this screen. And here's where you can download your data right now. So you can go ahead and do that. You'll get your data in CSV. You can click long format. That would be every row is one trial. We also have a format that's wide format, and Jeremy will go into this. That's every row is one participant. But if you click your download data, then you'll have your own data that if this was a longer experiment, you could analyze. And if your students just participated in an experiment, they can immediately download their data and start looking at how the data appear after participating. So it's a nice direct connection to experiencing participation and then seeing your own data right away. You can also get back to data after you've participated in an experiment. So if you say you've participated in 5 experiments or 10 experiments, you can always get back to the data that you generated as a participant. You go to My Home, you click on My Home, and then you click on My Experiments. And when you do that, it takes you to the My Experiments page. And on the left here, you've got experiments finished, and it's got a list of all the experiments you've finished as a participant. And down here, you could click on this link and get the wide format data or the long format data again. And over here on the right, you've got experiments that you've designed. And so there's other ways to interact with experiments that you've designed. So My Experiments page has both of these things, all the experiments you participated in and all the experiments you've designed. And you can access your own data for the experiments you've participated in. And for the experiments you've designed, you can access all the data, everybody who participates. So if you want to continue the interactive component of this, you could also go to that same demo we just did. And there were 2 links that appeared. The first one was this chain link to participate. The second link copies a version of that experiment into your own account. And if I go back, that experiment would then appear over here under experiments designed. It would say, VSS demo 2020 demo copy, because you just copied it into your account. And you could rename it and you could modify that if you'd like. So I'll show you sort of a teaching exercise you might do with an experiment like this in your class. The interface for designing the MOT trials lets you set parameters, and there's a number of different parameters for each trial. But here's the parameters of the 3 trials you just completed. So I've classified these as easy, medium, and hard. This would not be a good experiment. It would be an inadequate experiment because there's a bunch of confounds. There's different numbers of targets in each trial. They're also moving different speeds, and they've got a different likelihood of changing direction rather than moving ballistically. So with these sets of parameters, you could show these to students and ask them, what's the difference between performance on easy, medium, and hard? And then they tell you, there's all these differences across the different conditions. That's not a good design. And so then you can introduce the idea of control. If you want to control and just test for capacity limits, then you hold the speed constant and the swerve constant and just change the number of targets. Likewise, if you want to test the speed limits, you hold the number of targets and the swerve constant and just change the speed. So pretty quickly, you can generate new experiments that have these parameters, or you can have your students do it, which is even better, and teach them about the idea of controlling variables in their own experiments. All right, so there's another way to create a new experiment besides clicking on this, the two pieces of paper, copy the experiment into my account. If you go into any one of the experiment pages like MOT or change detection or memory, there'll be a button over here on the right, which is the E+. So if you click on this, it'll create a new experiment for you that's going to live in this part of the website. It's going to appear in the MOT section, for example, if you were to click it here. If you were in the memory section of the website and you click the E+, then your new experiment would be displayed in the memory section under experiments. So when you do that, it'll say, success, a copy of the experiment is in your account. Start editing and publishing it today. Another way to get back to any experiments you've created. So if you just clicked on the E+, to get back to the experiments, you click again on My Home and then on My Experiments. And that'll bring you back to the same page. And now under Experiments Designed, you'd have New Experiment if you use the E+, or you'd have something that would say, the experiment name that you copied, and it would say copy next to it. So pretty easy way to start making new experiments, both for you, if you want to use it as an instructor and make great experiments to show as demos to your class, or if you want your students to make experiments, it's also pretty easy for them to get started. And now that you've got a new experiment, you can edit that experiment. So you can click on this icon, which appears next to each of these. And the experiment editor. So this is sort of the main feature of TELLab. There's a number of options when you enter the experiment editor. There's frames, settings, and tags. If you clicked on settings, you could change the name of the experiment. But frames is really the meat and potatoes of the editor. So when you click on frames, it'll give you this navigation window. And if you want to add content to the experiment, you click on this plus symbol down here for add a frame. Once you've added a frame, a number of different options are going to come up here. You've got a block, which is sort of a structure. I'll explain what each one of these buttons means. But first, if you just wanted to make instructions, you want a screen with instructions, you click on text. And once you do that, it'll create in the editor, I think it says HTML, it's got a few options. And now you can just type the text right in. So I did this as I was making that demo initially. You just type the text right in for your instructions. And going back, if you wanted to enable different keys, in this navigator, there's the rightward arrow icon next to the trash icon and the star. If you were to click on that, that would let you decide which keys make the trial advance. If you had correct things or incorrect things, you could set it up there. So I'll come back to that. So we can add instructions. And now, first we use this add a text frame. And now we can say add an MOT frame. So an MOT trial, if you click on this, it's going to initialize an MOT trial. It'll let you add an image. So whatever you want your target object to look like and distractor object to look like, you can pull a file from your computer. You can save these files in your TELLab library. So any image files, any stimuli files that you want, you can save them on TELLab and you can browse there, or you can just pull new things off of your laptop. And then it's going to give you a bunch of boxes like these to set the parameters. So how many targets do you want here? And then there'll be another prompt that says, how many distractors do you want? You can set the speed. So the speed here, and then it gives you a little bit of information below, saying that this speed is in pixels per second, I believe. Yeah, pixels per second. And it tells you a good range, 60 is slow, 240 is fast. So you're probably going to want to set your velocity somewhere between those. There's different ways that the objects can interact in a multiple object tracking trial. So you can have them stream past each other. So they just sort of, stream right through each other. You can have the objects bounce off each other, or you can have them avoid each other. So there's a little force field around the objects, so they never actually make contact. So here I can click one of those three options. I'll choose avoid. And now I can set the repulsion. So how far apart will the objects be when they avoid each other? And that's two radii of the size of the image that you used for the objects. And then how much do you want the objects to swerve? How often do you want them to spontaneously change direction versus move like billiard balls? So here a 0 is a billiard ball. And as you increase this, it can let the object spontaneously change direction a little bit each advancing frame by 0 degrees, 1 degree, 10 degrees. You can set that. So when you set that number high, the multiple object tracking objects start looking a little bit like gnats buzzing around. They're constantly changing direction and jittering. When you set it to 0, they look more like billiard balls. So that's how you might interact to create an MOT experiment. If there's time later on in the presentation, I could come back and I could actually share my screen while I create a new MOT experiment or edit the one that we have there. But I'm going to just leave that as a placeholder for now, that it's relatively straightforward to interface and to create new trials. And then there's good ways to organize those trials into blocks and into full experiments. So I'd like to give a little bit more general overview of the experiment editor and quickly describe what some of those other options are, what some of the other buttons that I just previewed are. So back here in TELLab, My Experiments page, you can click the Edit Experiment. We're back here, we're in the experiment editor, these options. We got frames, we want to add content. And so now, what do each of these different buttons do? So the real basics are the ability to make a text screen, a screen with text that you can write on, or an image screen. So these are just, they're single screens that will have options for how participants will respond. It can be press any key to continue if it's just instructions, or it could be a stimulus and you're deciding, should I press the right arrow key or the left arrow key to respond to the stimulus. With these two options that you create single screens that then can either be presented for a fixed amount of time or can require a particular type of input from the users. So that's the real basics, the backbone of building new experiments. And then if you click this, it'll allow you to create blocks inside the editor. And so the blocks will let you randomize the order of trials, of these image trials, and to repeat trials if you wanted. So, you know, familiar block structure. If you've got 4 different trial types and you put them in a block and you want every trial type to appear 10 times, you can set that up with the block interaction. And if you want it to be randomized, you can randomize. But then we've got a few more sophisticated types of options here. Well, actually, I'll come back to the sophisticated ones, but I want to say quickly that students can do a lot with the basics. So just these simple things of being able to add text frames and images and organize those into blocks, you can build a fair number of simple experiments and collect reaction time data and accuracy data. So here's an example. You can have your students build a flanker experiment. They literally just make 4 image files for the 4 different types of trials. Here we've got congruent over here on the left and incongruent on the right. So that students could create those 4 trial types in Keynote or PowerPoint or whatever editor they want to, turn them into image files, upload them, and then they can configure those trials into blocks. And now they've got an experiment just by being able to display images and collect reaction time and accuracy data. So here's an example that one of my students did in class. The same concept of a flanker experiment with congruent and incongruent. They used, I think, Photoshop and made a congruent versus incongruent, light side versus dark side experiment with characters from Star Wars and settings from Star Wars. So on the left here, we've got congruent, dark side, light side, and then we've got the dark side character and the light side background. These are just a few sample stimuli they made for an experiment. I think they had 8 different characters total and 4 different backgrounds. So they made all the different combinations and built an experiment with a simple interface of just putting in images. And then, I don't know if you can see it here, but down below it's got the 2 button options for L and D. So you're supposed to respond to the character, L for light side, D for dark side. So they could figure out, who was really familiar with the Star Wars universe by the size of their congruency versus incongruency in this experiment. All right, so some more sophisticated trials. We've got MOT, change detection, and visual search. So each one of these buttons will let you create a specialized type of trial. I just showed you a little bit about the MOT interface where you put in the parameters. Change detection is, will let you upload 2 images. I'll walk through an example of that in a moment. Visual search will let you also input an image, and then you can just highlight with a little red square where the target is, and it lets participants click on the target when they find it. So these are ways to make individual specialized trials. But then we've also got a couple options here that will automatically generate entire experiments. So the IET will create an implicit association test. If you put in the categories and the stimuli, it'll generate a full counterbalanced implicit association test. This memory button lets you do a short-term memory test where you put in lists of items to present to participants, and then it'll generate the experiment for you. So have a full range. We've got everything from single screens with instructions, the specialized trials, up to a couple examples of full experiments, and then blocks let the students make structure to their experiment. So I'd like to do one more demo on your own computers. So go back to experiments. If you navigate back to the TELLab website and go to experiments, and then go to change detection. So first click here, experiments, that'll take you to this page, and you'll see change detection. You might have to scroll down a little bit to see change detection. And then when you click on that, we're gonna do the same thing we did with the MOT demo. You're gonna search for VSS within the change detection experiments, and you're gonna find this one, VSS 2020 change detect demo. And you're gonna click on this to participate, and there's just gonna be 3 pretty basic change detection trials that you can go ahead and do right now. I'm going to pause for 40 seconds.
In this particular experiment, the students do make their own stimuli if they want to, and they're quite creative about it. And there's a little box, a response box that you can put around where the change is, and then you have to put the cursor where the box is. And so that's all. It's easy to use.
Yeah. So go ahead and check out the demo.
Anybody getting it?
Hey, Justin, while people are doing that,
Yeah.
how about if one of us actually does it? Just to show what it looks like.
Oh yeah,
And I'm happy to do that if that's,
Let's try it.
yeah, I'll share a screen for a moment. Here we go.
Sure.
Okay. Okay, here we go. So here we go. Okay. Okay, so if we click up in the corner here, or if we make the experiment wide enough, we can see sign in. And then here's the screen where I'm going to just sign in, but you can create you could register for a new account. And I'm going to go to I'm going to go to experiments here. And then we have all the different paradigms. Going to go to change detection right there. I'm going to do a find for VSS and click right here on the little link. And we load up here. And now I think the thing that was happening for Angela is that sometimes it's necessary for this little part right here to be active in order for the experiment to work. So sometimes if this part over here gets active, it's necessary to click somewhere around here. So here we go. Okay. So we can look at the difference.
That's pretty easy. That's got an artifact there. Yeah, that didn't work.
I'm the perfect subject for this because I once had a beard, and there it is right there. So I click on spacebar. So down here it shows which keys are possible to press. Click on spacebar, and then I'll click over here where I think the change was. You got it, and it sees if I'm right or wrong, and it measures the amount of time until I click the spacebar. So I am awful at this, so, but I did preview it, so got that one.
So you can see that it's choppier coming through Zoom than it is on your own desktop, which is part of why we directed you all to do it on your own machines.
Mm-hmm. Yeah.
And that's something you'd want to do with students as well.
Mm-hmm.
All right, so as Kim was saying, it's a great exercise for students. If they want to make a change detection experiment, they can create a pair of images in whatever editing software they like. I like Keynote, but you can do it in PowerPoint, iPhoto, Photoshop, whatever it is. They can find an image off the web. They can take a photograph themselves if they want. All they need to do is create the pair of stimuli. Then they save them as image files. And importantly, max dimension 640 by 640 is the maximum dimension in pixels. And then they can just follow the prompts on TELLab. They upload both images. They can set the ISI between the presentations, the duration time. And so they can build a change detection trial is almost as easy as just making the stimuli themselves. So it's a nice way to pretty quickly get students engaged. And they love doing this. They love editing their own images, trying to put something tricky into the image, or trying to see if people's attention is drawn to things that are threatening, or if it's drawn to attractive faces, or they test all sorts of things once you give them this opportunity to create their own change detection. Yeah, so I mentioned here that if the images are the wrong size when you upload them, then it doesn't work. So TELLab 1.0 has some quirks. So this is one of those quirks that the image files have to be a particular size. And as you poke around on the site, you're going to see that there's other quirks, there's other clunkiness about it. But it also has a bunch of things that work really well. So yeah. All right, so you can create a change detection trial. I'm not going to do that right now. I mentioned already that there's a way to create a memory experiment, a short-term memory experiment. And this is specially set up for the DRM, D. Schrodinger-McDermott false memory paradigm. So you can create a memory experiment and a false memory experiment if you want in about 10 minutes. Once you've explained how to do that, I'm not going to get into the details. Similarly, the IAT button here will generate an entire implicit association test with, I think, really, really smart defaults. It gets the instructions right. All the students have to do is come up with their categories and their stimuli. There's also some hidden functionality. I'd like to say that's like in and out, that it's there intentionally, but really some of it's not the best user interface in some ways. So there's a way to create card sorting trials as well. So if you wanted to make a card sorting experiment and you went to people watching, and then you created a new experiment by clicking the E+ sign within people watching, now when you add a frame to that experiment, it's going to present this option that's not there on the other add a frame menu, card sorting. And so if you were to click that, then you could upload a number of images, and you've got a card sorting interface where you can drag and drop these faces. Students also really enjoy this, rating faces on trustworthiness, attractiveness, dominance, all sorts of social perceptions in images is something students find really interesting, and there's a nice, pretty slick user interface.
For you color vision people, I got the idea from the D50, is the inspiration for it.